So, I thought for the first 20 minutes or so of today's class, we could go over problems from the homework. My Tuesday, Thursday class, I went over mostly part 1 homework. So today I'm going to go over mostly part 2 because y'all also have access to those lecture videos. And I'll be posting the part with the lectures right after class today. So having said that, let's look at a couple of the part 2 homeworks. Let's start off with these first 3 problems. These first 3 problems, just trying to find the derivative of different functions. Let's start off with number 1. So we're given that the function is equal to the ln of 3x. Well, we know from past lectures, get this back open, that the derivative of ln u of x is equal to 1 over u times the derivative, right? Excuse me. So here, if we imagine 3x as our function ux, we're going to get that prime of x is equal to 1 over 3x times the derivative of 3x going to come out to be 1 over x, right? People at home, can you hear me? Yeah, I'm not muted. All right, cool. So in the next problem, we've got another function. Let's call this one g of x. It's equal to the ln of 4 minus x to the 8th. So again, applying the chain rule, we're going to get that g prime of x is equal to 1 over 4 minus x to the 8th times the derivative of 4 minus x to the 8th, which is just going to come out to be 1 over 4 minus x to the 8th. That quantity times 8 times x to the 7th. Now, this last example, h of x is equal to the ln of the 5th root of 8 minus 7x. Here, it's going to be helpful if we rewrite this first. So rewriting it, we're going to get the ln of the quantity 8 minus 7x raised to the 1/5 power Well, we have a power property of exponents, right? I mean, of logarithms. We can just pull this power right out, can't we? So let's do that. 1 over 5 times the ln of 8 minus 7x. So taking the derivative of this, now we have this constant that we can pull out, and we're just taking the derivative of this bit right here, right? Agreed? So doing that really quick, 8x primed is going to be equal to 1/5, 1 over 8 minus 7x times the derivative of 8 minus 7x, that's just going to be 7, right? Negative 7, I mean. So now we can simplify this even further. We can multiply our denominator by 5 and our numerator by negative 7. Distribute that negative through our denominator to get 7 over 35 x minus 40. So far, none of these are particularly rough. They just take some massaging of the algebra, right? So let's jump to some more problems. Let's check out 5 and 6 here. Actually, let's check out 5, 6, and 7. These will all three be good. In the case of 5, we've got f of x is equal to the ln of x over x to the 8th. Well, here we're going to need to apply the quotient rule, right? Quotient rule is going to tell us that this is going to come out to be the derivative of what's above times what's below minus what's above times the derivative of what's below all divided by the square of what's below. Notice there's some simplification here, right? Simplify this, then we're going to be able to pull out an x to the 7th. So doing all of this, we get x to the 7th minus the ln of x times 8 x to the 7th, all divided by x to the 16th. Factoring out that x to the 7th now, we have 1 minus 8 times the ln of x all divided by x to the 16th. Well, we can factor out or cancel this x to the 7th with this x to the 16th, right? Agreed? We can rewrite this as x to the 7th. Let me write it like this. X to the negative 16th. X to the 7th.
Why is it negative?
I'm pulling the negative up. Makes sense? So I'm pulling the denominator up. And to do that, we just have to make that exponent negative, and we can rewrite it this way. We're going to get 1 minus 8 ln x in this term, or this factor rather. Now these share a base, so we combine them under exponent rules, right? When we do, we get x to the negative 16th plus 7 times 1 minus 8 ln of x we can simplify this exponent, right? That power. This will come out to be 1 minus 8 ln x all over x to the 9th. So all we're using here are a bunch of our power rules, exponent rules, and the quotient rule, right? We're not reinventing the wheel, we're just following the rules. All right, so let's look at this next example. The ln of x over x squared plus 6. What do y'all think we should do here? I'm going to let y'all tell me what to do on this problem. Well, I can't talk. It's too damn early this morning. The first thing we can do is break up this ln, right? We have that property where we have the ln of A over B. This thing's going to be equal to the ln of A minus the ln of B. So we can take advantage of that, make this a little bit easier on ourselves, right? This is going to come out to be the ln of x minus the ln of x squared plus 6. And already this looks like it's going to be better to work with, right? So f prime then is going to be equal to the derivative of the ln of x x squared plus 6. Well, this thing's just going to be 1 over x. This thing's going to be 1 over x squared plus 6 times the derivative of x squared plus 6, right? So f prime of x is going to come out to be 1 over x minus 1 over x squared plus 6. That quantity times 2x. And now from here, we could simplify this more if we wanted to, right? Like we could bring it all into one fraction and make it look nice and neat, but for the most part, we're pretty much done here. All we're gonna really wanna do from this point on is rewrite it accordingly. Like I said, we could of course cross multiply and simplify our fraction and do all that nice, neat jazz, but for what we're doing, this is good. Good enough, anyhow. What about this example down here? How's that going to work out? I'd like for y'all to work on that for just a minute. Give y'all about 2 minutes, actually, to work on this problem down here, 7. So what do we think? What's the first step here? Exactly. Let's make this easier on ourselves and break up this ln. So this first step, and break them up into the ln of 2 minus x, all raised to 5 over 4, minus the ln of x raised to the 4 over 5. Now what? Take advantage of the power property of logarithms, right? Yeah, just pull out those powers. So let's do that. We're going to get 5 over 4 times the ln of 2 minus x minus 4 over 5, the ln of x Yeah, that's a lot better to work with. So what's the derivative of this first term? Don't worry about the constant out front, just think about the ln here. What's this derivative? Well, it's going to be, let me rewrite this, f prime of x is equal to 5 over 4. It's going to be 1 over 2 minus x times the derivative of 2 minus x. And then, of course, over here, pretty much going to be done right away, aren't we? Well, the derivative of this thing comes out to be -1, doesn't it? This bit right here. So what we're going to be left with then is 5 over 4 times -1 over 2 minus x minus 4 over 5 times 1 over x. Now I propose we pull this negative down to our denominator and just flip our terms, right? So that we write it like this. This thing is going to be 5 over 4 times 1 over x minus 2 minus 4 over, let's go ahead, bring this all into one fraction. Now we can simplify this some more by bringing in our fractions, right? By multiplying our denominator by 4, and our numerator by 5. And when we do that, we're going to get 5 over 4x minus 8 minus 4 over 5x. We can keep simplifying this further and further down. But for our purposes, I think this is good enough.
Couldn't you just minus the 5 and the 4, and that would just end up being 1 over, and then it would just be 1x minus 8.
Do what?
Never mind.
Not quite, because we still have to get these shared denominators so that we can actually do the addition or subtraction in between them. But yeah, pretty much done after that, aren't we? Other than a little bit more simplifying. So let's leave it at this for right now. All right, change of base, change of base, change of base. I really like this 13 here. This 13 and 14 look like two good problems. So for the record, I'm doing this for two different reasons. One, because I gave y'all a lot of homework, and I knew I did this time around. And I did that with the plan of going back through like this. The other reason is because it's just good practice. We don't do a whole lot of this in this class. I like the idea of going back and looking at problems every now and then and actually just working them out. So for this first problem, or for number 13 here, we've got our function is equal to x times 4 raised to the x plus 7. Now I propose we make things easier on ourselves, and we rewrite this exponent factor here. I say we rewrite it as x times e raised to the ln of 4 times x plus 7 I think this makes it easier on us. That way we don't have to think about the derivative of something like this, right? We just go ahead and rewrite it as the ln. I think it makes this easier on us. So let's go ahead and rewrite it like that. Now, from properties of derivatives, we know if we have two functions, g of x and h of x, we're going to take the derivative of their product. This thing is going to come out to be prime of x times h of x plus g of x times h prime of x. Agreed? We're going to have to apply that up here. We've got an x and we've got this exponent, right? It's exponential. So f prime then is going to be equal to the derivative of x times e raised to the ln of 4 times x plus 7 plus x times the derivative of e raised to the ln of 4 times the quantity x plus 7 this thing is just going to come out to be e raised to the ln of 4 times x plus 7. This thing over here on the right, this term, we're just going to multiply e raised to all of this times the derivative of our exponent, right? So this thing is going to come out to be x times e to the ln of 4 times x plus 7 times the derivative of ln of 4 times x plus 7. Right? What's the derivative of this? Just the ln of 4, right? So once we get done with all these reductions, we're going to have that f prime of x is equal to, I'm going to go ahead and simplify this by factoring out that ln of 4, right? Go ahead and put it back in as our base. So we're going to have 4 x plus 7 plus 4 x plus 7 times, hold on, let me rewrite that. X times 4 to the x plus 7 times the ln of 4. Right? Everybody agree? Well, hey, we've got a 4 raised to the x plus 7 that we can factor out, so let's go ahead and do that. When we do, this simplifies to 4 raised to the x plus 7 times 1 plus the ln of 4 times x. So really, a lot of this is just going to be applying these rules and simplifying. Now, in this next question, 14, we're given a function and we're asked to find a tangent line to that function at a point. All right, our function is equal to the ln of x raised to the 9/5, is that right? So, we want to find, I'm going to go ahead and rewrite this. We want to find the tangent line to our function at this point. Well, really quickly, let's make sure this is a point on our function. If we put in 1, we're just going to get the ln of 1, right? Because 1 raised to the 9/5 is still just going to be 1. Agreed?
Supposed to be 9/2.
9/2?
Yeah.
My bad. Still going to come out to be 1 though, right? So it's going to be the ln of 1 raised to 9/2, which is just the ln of 1, which is just going to come out to be 0, right? So this is in fact a point on our function. Now let's think about the tangent line. The tangent line is going to be the line y minus 0 is equal to m times x minus 1, right? Or x naught, y naught, y minus y naught is equal to m times x minus x naught, right? Where m is going to be the derivative of our function at 1, 0. So we're going to have to calculate the derivative at that point. Cool? So let's find that derivative. F prime of x is going to be equal to 1 over, well, actually, let's rewrite this first. Go ahead and pull out that exponent, can't we? What I am trying to say is we can go ahead and say f of x is equal to 9/2 the ln of x, right? It's just going to make the math easier on us. So f prime is going to be 9/2 times 1 over x. Yep. So when we put in 1 for x, this thing's just going to come out to be 9/2. So our tangent line is going to be y minus 0 equal to 9/2 times the quantity x minus 1. This is going to be y is equal to 9/2x minus 9/2. That's all she wrote. We're just combining everything here, right? A bunch of the stuff from earlier in the semester. We know what the equation for tangent lines are. We know how to find the derivative of these things. Now we're putting it all together. Yeah. All right, so let's look at another problem. Yeah. Let's find dy dx for this implicit derivative. That's a good one. I feel like I sounded way too excited about that. And truthfully, it is too damn early for math. I'm not gonna lie to y'all. I feel it. I know how y'all feel it today. All right, so for this problem, things change just a little bit. We've got the ln of x times y plus 6x is equal to 10. What's the first thing we want to do here?
Aren't you gonna put that 10 on the other side?
Not yet. It'll actually make things easier for us this time if we leave it there. So the first thing I would do here is I'd break up that ln right away. I'd say that sucks, I don't like it. Write it as the ln of x plus the ln of y plus 6x is equal to 10. Okay, that looks a lot better. Let's take the derivative of both sides now. And this is why in this case I would leave the 10 here. Makes sense. Because now, what we're going to have is the derivative of ln of x plus the derivative of ln of y, which I argue is where the mistakes will happen. The derivative of 6x. The derivative of a constant is 0, so this is all equal to 0. This derivative, we know it's going to be 1 over x, right? This derivative, we're going to have to apply the chain rule to, because we're thinking of y as a function of x. So we're going to have 1 over y, but then we're going to have dy dx plus this derivative is just going to be 6. It's all equal to 0. Now, let's subtract this term so that we can isolate dy dx from everything else. Multiplying both sides now by negative y, we're going to get negative y times 1 over x plus 6 is equal to dy dx. That's all she wrote. So how's this stuff feeling so far? Like, how's the homework? How's this material feeling? Pretty good? Awesome, good. I ask because, one, exam 3 will be next week. It will cover all of chapter 4 up to 5.3. We're gonna finish up, we're gonna start 5.3 tomorrow or Friday. And we'll be done with it by Wednesday. Yeah, I know that was a quick turnaround on exams, right? Like compared to the first exam to the second exam, second and third was a quick turnaround. I actually am pushing this one off. It should have been this week according to the schedule, but I just felt like there wasn't enough in chapter 4 to really have an exam over. There's too much between 5 and 6 to make one exam. So this is my way of working around that. Bring 4 up to 5.3 together, and then 5.3 to the remainder of the semester will be exam 4, and then the final will be everything. So having said that, between the two exams, exam 3 and exam 4, and the final, there's about 40% of your grade right there. Plus you have about a third of the homework left for the semester. Roughly a third, about a month, right? So I just wanted to, like I said, go over these problems because yeah, this homework was dense and it was dense by design. There was a lot going on. So I wanted to kind of go over those problems to help wean off some of that work for y'all. But also, just because I think this is a good review before we get into chapter 5. So do y'all have any questions? No, no questions? All right, well, in that case, you all are free to go. I'll be the Zane. So long, farewell, adieu. I will stick around if you all have any questions.